So since we're starting at rest right here at the origin, again, VI is equal to 0. The acceleration is 5 right now because that's the speed, or the acceleration that Dart is traveling on the broomstick. We know the engine cuts out at 200 meters, so that's your displacement, because that is what we're stopping this problem. H for displacement. So what we can do with this is we can use this to find the time and the final velocity Dart had when he was there. So what we do for that is we plug in VT plus 1 over 2 AD. Whoops. So we can use this little handy formula for it. So VI is 0, making this whole thing 0 right here. So it's 1 over 2, 5, and time squared equals 200 meters. So then 200 equals 2.5 t squared. Oh, okay, you know what? It's not 5 meters. It's, well darn. Well, shoot. Okay. Great. So I lied. It's 15 meters. 15 meters per second is the actual acceleration, and I'm done. So that changes this to 7.5, which means that this problem is, for this problem, t equals 5.16397. So that is one of our final answers. But we still need to find the final velocity for this section before we can move on to section 3. Okay. So for section 2, or well, that's sections. Jeez. Okay, so we have our times. We need to find the final velocity of this section for at least. So VF squared equals VI squared plus 2AD. So VF is our variable we're searching for. VI is 0. 0 plus 0 times 0 is 0. So 2, 15, 200. So that gives us 400 and, okay, so 6,000 is VF squared. The square root of 6,000 is 77.4596. So 77.4596 is our final velocity for this section, giving us another answer as to how fast Dart was going in the final, when the magic shut off. Moving on to section 2. Alright, section 2. So we found out Dart's final velocity for the first section right here is 77.4596. So that means the initial velocity for the second section is going to be the final velocity of the previous section. So again, that is going to be 77.4596. So we know that gravity is now acting upon this because it is in free fall. Well, it's not free fall because it's still being affected by the momentum that it had from the initial liftoff. But regardless, gravity is affecting it at negative 9.81 meters per second squared. And we also know that your final velocity here is going to be 0 because it gets to the top right here and kind of plateaus. So it's going at a positive velocity all the way up to here, and then it starts going negative. So in between the positive and negative, you get 0. So that's what we have for right here. So we can use the formula for finding distance, do the same thing we did before, but find the maximum height right up here. So max Let's just do it right now. So d equals t plus 1/2 a t squared. So that is d equals 77.459 times t plus this is the wrong formula. Cut this, please. Forgot. Okay, so section 2, we're gonna find the maximum height that dart got to on this point, which is the point right here. For that, we're gonna use the formula vf squared equals vi plus 2at, yeah, vi squared. So we just got to start plugging in. 0 times 0 again is 0, so vi 77.459 squared plus 2. A now is negative 9.81 because it's gravity, and d is our variable we're searching for. So 77.459 squared is 6,000, 0 plus 2, and those variables together are 2 and 9.81 are negative 19.62. Negative 6 goes to the other side. Well, it goes to the other side and becomes negative. So we're left with that. So divided. And that gives you d equals 305.8103. So that is the maximum height that dart reached when he was getting to that final point. On to the third section. Wait a minute. No, we still need to find time. So, okay, so now to find time, we have to use Bf equals Vi plus At. So to get t in this sense, we need to start plugging in again. 0 equals 77.4596 plus 9.81, that's negative t. And that will give you a grand total of 7.89. Wait, do I even need this? Yeah. 598 seconds. So that's how long from, so that's the totality of section 2. So I think we're a lot today. Alright, so this last section here, what we have is the acceleration is going to remain the same because it's just gravity being acted upon, well, gravity acting upon an object, and your displacement for this instant, because we're taking it from the highest point, is the highest point we got in the last equation, which is again 305.8103. So what we're going to do with these is plug these three into a formula. Which one? So Vi squared. Oh yeah, so Vi is Vi 0 since we're taking it from this point right up here. And again, the Vf from the last problem is going to be the Vi from this problem because we're just taking it up right where it left off. Yeah, and it plateaued, so it's 0. So wow, I'm just dumb. Okay. Okay, so this gives you a final velocity of well, this squared is 6,000. So your final velocity is 77.4596 meters per second. But since you're moving downwards like that, it's a negative because physics. And we still need to find time in this situation. So what we can do for that pretty easily is, oh boy. Okay, so what we can do for this is d equals VIT plus 1/2 a t squared. So that's 305.81/3 equals 0 plus 1/2 9.81 t squared. T slight. Why is that in the video? Okay, so negative 19.62. It's weird talking with this. Which gives you a time okay, and that gives you t squared equals negative 15.586. To square root this, you just go like that, and t would equal a positive 3.9. Well, technically it would equal a negative and a positive because it's a square root, but for this instance we have to pick a positive because you can't have negative time. So it's a positive 3 as opposed to a negative 3 seconds. So yeah, so we found all the times and all the final velocities for this problem. Didn't even need this last section, just, threw it in there. Fun guy. Yeah, physics is dumb.